So we're going to be having a test here soon, and I call it a question here, but there's going to be two parts. A calculator portion that's going to have rationalizing fractions, solving square root functions, and then a non-calculator portion where you're going to be actually graphing the function and finding the domain of the square root of the functions. So I've got it highlighted here that we're going to be looking at the calculator portion of the review here. And here on question 1, there's multiple parts, but we're simplifying each of these square roots fully, rationalizing the denominator where necessary, and we want to make sure to write our answer in simplest fraction form and or simplest radical form, which is also sometimes known as exact form. So as we take a look at the square root of 32, we're going to make our factor tree here, and I'm going to start with 16 times 2. Which is 4 times 4, and 2 times 2, 2 times 2, and then I'm going to carry down that 2. And what we need here are 2 of the same value to take out 1. 2 2's, I'm going to take out 1. And I told you on the last video that sometimes people cross it out. 2 of the same, take out 1. So we took out those values and notice that we still have a single 1 left underneath our radical. And we can finish here. 2 times 2 is 4. Square root of 2. Letter B. 5 times the square root of 49. Well, the first thing that we need to notice is that there is a negative underneath the square root. And consequently, when we start this, it's going to be the square root of negative 1 times the square root of 49. The square root of negative 1 is I. So this is going to be 5, which is already out in front of our radical, I, times the square root of 49. And the nice part about 49 is that it's a perfect square. We know that the square root of 49 is 7. So when we finish this problem, 5i times 7 will give us 35i. Now, compare letter B to letter C here, not to be confused, because on letter B, the negative was underneath the square root. This time our negative is outside. So we're going to simplify this. 24 is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. And once again, we need 2 of the same value to take out 1. 2 of the same value to take out 1. We have a single 2 and a single 3 left underneath the square root, and that's going to give us 2 times 3, which is 6. And lastly, there was a negative outside of the radical, so we need to keep that negative outside the radical. Letter D looks like we're going to have to rationalize. If we take a closer look here, remember we can break this fraction apart and we get the square root of 11 divided by the square root of 4. Once you rewrite it like this, ask yourself, can you simplify any radical? Well, we can't simplify 11, but we can simplify the square root of 4. It is 2. And we do not need to rationalize because there is no radical, there is no square root in the denominator. But I'm guessing as we move on down here, if I flipped that fraction over now to the square root of 4 over square root of 11. Once again, we can break this apart as the square root of 4, square root of 11. And can we simplify anything here? And the answer is yes. We can simplify the square root of 4. But the difference on this particular problem compared to the last one is that we have a radical in the denominator. Radical, also known as square root. And to get rid of the radical in the denominator, what we're going to do is we're going to multiply by the square root of 11 down here in the bottom of the fraction. If we multiply the bottom of the fraction by the square root of 11, we need to also multiply the top of the fraction by the square root of 11, which we sometimes call a fancy form of 1. Now, what we end up with is we end up with 2 times the square root of 11 in the top, Square root of 11 times 11 is square root of 121. And lastly, can we take the square root of 121? Because our goal is to get rid of the radical in the denominator. And we can't. It's 2, the square root of 11, or 11. Letter F. We still have a radical in the denominator. Not quite as complicated as letter E, because we can dive right into this, getting rid of the radical in the denominator. We're going to multiply the bottom of the fraction by the square root of 7. And if we multiply the bottom of the fraction by the square root of 7, we need to multiply the top of the fraction by the square root of 7. And 1 times the square root of 7 is the square root of 7. Square root of 7 times square root of 7 is square root of 49. But again, ultimately our goal is not to have a radical in the denominator. Can we take the square root of 49? And we can. We end up with the square root of 7 divided by 7. Letter G. Same idea on letter G. We want to get rid of the radical in the denominator. The process is going to be the same. We're going to multiply the bottom by the square root of 15. We're going to multiply the top by the square root of 15. And we end up with 3 times the square root of 15 in the top. By the way, square root of 15 divided by square root of 15 is a fancy form of 1. Down here, this gives us 225. But we don't want a radical in the denominator. Can we take the square root of 225? And it turns out that yes, we can take the square root of 225. It's 15. Now, it's good here. We did get rid of the radical in the denominator, but we can do one more thing, for lack of better words, to this. We can simplify. 3/15, and if you need your calculator, then just type in alpha y equals for your fraction button, 3/15. And what you see is it becomes 1/5. So you might write this as 1 square root of 15 over 5. Or you might just write square root of 15 over 5. Either way is fine. Letter H. Letter H is a little bit longer, just to give you a warning. So if you have some space, you might want to start a little bit to the left. The first thing that I see as I take a look at this problem is that square root of 8 can be simplified. And I'm always trying to simplify first in hopes that it will help a little bit. And remember that 8 is 4 times 2, and 4 is 2 times 2. So ultimately what we have is we have 2 times 2 times 2, and we need 2 of the same to take out 1. So up top here in our fraction we've got 2. We took out a 2 and we still have a 2. We took out a 2, that's one of them. And down here in the denominator we still have the square root of 6. Well, 2 times 2 is 4 square root of 2 over square root of 6, which I'm going to promptly write again because I don't have enough space. So underneath this, 4 square root of 2 over square root of 6. And what we're trying to do in problem number 1 is we want to get rid of the radical in the denominator. So we're going to multiply by the square root of 6 here. We're going to multiply by the square root of 6 here. When we do that, we end up with 4 times the square root of 12 divided by the square root of 36. Well, no radicals in the denominator. That's our mathematical rule. So it's 4 square root of 12. We can take the square root of 36, which is 6. And then once again, what we see is we can simplify this. And if you need to, you pull out your calculator and again you go alpha y equals to your fraction button, 4/6 gives us 2/3. And you don't have to do that right now, but we've got 2/3 times the square root of 12, and everything looks good, except that we can simplify the square root of 12. So we need to make sure that everything is simplified completely when we're doing these problems, and I warned you ahead of time that this was going to take some space. But 12 is 2 times 2 times 3. And what we're looking for are two of the same value. Take out 1. So this is going to be 2 times the square root of 3. And then this is 2 times what we just found, 2 square root of 3. There's our square root of 12 simplified. Divided by 3. But now finally we can be done with this problem because 2 times 2 is 4 square root of 3 over 3.